All right. So hello and welcome everyone. So we are live right now. I hope I'm audible and visible to all of you. Please let me know in the live chat. All right. So yeah. So welcome back to this amazing platform of Tutee Learning. So today in this particular lecture, we're going to discuss about the last topics, especially as the miscellaneous topics of the topic of definite integral. Now today's session, we're going to cover some of the most important sessions of the definite integral, especially for the purpose of question solving, right? So if you take up any JEE Mains and JEE Advanced questions, and if you try to solve those difficult problems, sometimes knowing the important properties, especially the Wallis theorem, actually helps you to solve integrals of trigonometric limits or trigonometric functions whenever the integral is going from 0 to pi by 2. So whenever you have that kind of integral which is going from 0 to pi by 2, in order to solve that questions, trigonometric and having trigonometric function, Wallis formula will help you a lot in solving the question very easily. So in today's session, we're going to discuss about the Wallis formula and something all the recursion things that we have already left up in the previous topics, right? So I'm going to discuss about that particular topic, and then we are going to discuss about the Wallis formula, right? So that will be our motto for today's class. And if time permits, I am definitely going to cover the beta and the gamma functions and the applications of inequalities. So those are the last three topics that are basically remaining behind, right? So let's see. Okay, and after that we are going to solve a lot of questions. Okay, so definitely there are going to be question solving sessions as well. In that question solving session, we are going to solve and look at different varieties of question that has been asked over the previous years, right? So with this particular thing, let's get started. So I hope you have solved this particular homework problem, and then you are basically coming to watch the session, right? So if you have solved these questions, I hope you must have got from the previous idea that we learnt about the Leibniz theorem, right? And we also learnt about how to convert an infinite series sum into a question of definite integral, right? So that was all we have covered in our last class. So similarly, I gave you some homework to practice. Let's see some quick solution of these questions, right? So if I take out the first problem over here, let's try to analyze the particular sequence over here or the series over here. So if I try to solve this, then if I look at the series n with the n terms, then this is basically, so n upon, so I can write it easily as n upon n square plus r square, where your summation r is going from 1 to n, right? Where your summation r is going from 1 to n, right? Now once we have this particular form, what I'm going to do is over here is that I'm going to first of all divide this that both the denominator and the numerator by n square. So if I do that, I get the relation 1 upon n in the numerator and whole divided by 1 plus r upon n whole square, 1 plus r upon n whole square, right? So that is going to be my relation where r going from 1 to n, right? Now once we have this relation, the next thing that I'm going to do over here after this is basically, we know that whenever we have these kinds of infinite series questions, we need to replace the wherever we see 1 upon n with dx, so this will be replaced with dx, and wherever we see r upon n, this will be replaced with x. So therefore this will be an integral going from 0 to 1, and the limits are decided by 1 upon n and taking the limit n tending towards infinity, right? So let me take the limit n tending towards infinity, and then it will go from 0 to 1, and the remaining result is 1 upon 1 plus x squared dx, right? This is a simple result, right? Now we all know how to integrate this result, and therefore if we integrate this result, the answer is going to come out as tan inverse of x from the limit 0 to 1. Okay, tan inverse of x within the limit from 0 to 1. I hope this is clear, right? Okay, so therefore if I put in the limits, then I'm going to get the answer as pi upon 4 minus 0, which is equals to pi upon 4. So finally the answer to this question is going to be equal to simply pi upon 4, right? I hope this is clear. Is this clear to all of you? So anyone who tried the solution of the question, are you all getting the answer as pi upon 4? Are you all getting the answer as pi upon 4? Please let me know. Okay, so please share these videos among your friends and the live with your relatives and any of your people who are basically preparing for the JEE Mains and JEE Advanced examination. Okay, say that we are live right now and we're going to discuss a lot of questions and topics and concepts that is going to help you out in your upcoming preparation for your JEE Mains and Advanced examination, right? Is that clear to all of you? Is this part clear to all of you? Please let me know. Please let me know if this part is clear or not. Okay, so let's quickly jump into the second prompt. So let us quickly see the solution of the second problem. So again, if we analyze the second problem, the relation can be simply given as limit n tending towards infinity summation of r to the power p upon n to the power p plus 1, which is very easy question, right? Where r going from 1 to n, which is a very easy solution. So this is will be limit n tending towards infinity, then we'll have r upon n whole to the power p into 1 upon n into 1 upon n. And again we're going to do the same solution, that whenever we look at these kinds of problem, wherever we see r upon n, we just replace that with x, and 1 upon n goes with dx. So therefore this will be integral going from 0 to 1 again, and it will be x to the power p dx. So if I simplify this, is going to be x to the power p plus 1 whole divided by p plus 1 within the limit 0 to 1, which is going to be equal to 1 upon p plus 1, which is going to be equal to 1 upon p plus 1. I hope this solution is clear to all of you. Is this solution clear? So the two questions that I gave all of you to solve, the answers are as follows. The first question answer is basically going to be equal to pi upon 4. That's the first answer. And the second answer is 1 upon p plus 1. 1 upon p plus 1. So these are the two answers of the questions, right? I hope this is clear. Is this clear to all of you? Please let me know, is this clear or not? I hope this is clear, right? Okay, and if you're new to this particular channel, please subscribe to the channel and hit the bell icon so that you don't miss out any upcoming notification from the channel, right? So every day on this particular channel, you can see that there are definitely live lectures coming up, especially on the difficult topics of mathematics, which are basically going to help you to prepare for the upcoming JEE Mains and Advanced examination. Yes, from this particular lecture only you can prepare from sitting at a comfort of your house by following the lectures and solving the question. You can also prepare for the JEE Mains and Advanced examination. Along with that, you require certain practice, so that you can always do by joining our live one-on-one batches. So the information is given in the description box. Please try to follow the information. And if you want to get mentorship and you want to get help from me, you can all contact us on this particular number. Okay. So you can contact us on this number to get one-on-one doubt clearance or one-on-one live classes. Okay. And along with that, we have already launched our one-on-one online batches. Please, if you want to get dedicated preparation every day, you are preparing for the examination and you want to get scheduled hours of classes and you want to see homeworks and want to give test series, then you can definitely enroll us with the online batches. Okay. So that will be a structured way of preparing for the examination. Okay, it is not only for JEE Mains and Advanced, it is also for your other competitive examination like WBJEE, okay, like BITSAT examination. And even if you're preparing for your school examination and you are from any other different stream, for example, if you are from the commerce background and you have taken mathematics as your in your class 12, then definitely you can also prepare with us from this one-on-one classes for your upcoming board examination as well. All right. So with this, let's go with the today's topic. So today, let us first of all discuss quickly some of the applications of inequality. Then we move to the topic of Wallis theorem, right? So if I talk about applications of inequality and what I basically mean by application of inequality. Okay, what is basically mean by applications of inequality, right? Sometimes when you are asked to prove inequalities involving definite integral or to estimate the upper and the lower bound of any boundary value definite integral, right, where the exact value of the definite integral might be difficult to find out, then in that case we try to find out the bound of the function. We try to find the bound of the function in terms of simple integral function, for which the definite integral is easy to find, and then we find and tell that the bound is basically lying between the following results, right? So let's quickly see some of the important results and the type 1 form Okay, the type 1 applications of inequality. So if you have any function which is defined on the closed interval a to b. Let us say that there is a function which is defined on the closed interval a to b, and first of all, whenever you have in this kinds of integral going from a to b f of x dx, the mod of this is always less than or equals to integral of a to b for the modulus of the same function within the given limit. Okay, so this is one of the very important results that you need to remember. Okay, and the equality sign, so you can see there is an equality sign. The equality sign holds true where f of x is entirely the same sign if f of x has the same sign within this interval a to b. Okay, so if everywhere f of x is positive or everywhere f of x is negative, then the equality will hold true, right? Otherwise there is an inequality. So please remember this, right? So we will see some questions regarding this. So let's quickly talk about the type 2 form of inequality. Now you might also have these forms of integral as, let us say I have an integral going from a to b for the same function f of x dx, and I take the sorry, there is another function. Okay, there is another function which is multiplied with g of x, okay, and both g of x and f of x are defined within the limit a to b. Then modulus of this particular integral for the product of this integral is less than equal to square root of integral from a to b for the function f of x whole square, okay, f of x whole square dx multiplied with the integral going from a to b g of x whole square dx, right? I hope this result is clear. Is the result clear to all of you? And please note that these both function f of x whole square and g of x whole square are both integrable within the limit a to b. Okay, so please note that these particular functions are integrable on the limit a to b, then only we are trying to give this result, right? Similarly, if I talk about the type 3, so if I talk about the type 3 form of applications of integral or inequality, so I can get, if I have f of x uh, and g of x both are defined on a to b, then integral going from a to b for the function f of x gx is greater than integral going from f of x gx a to b for the function g of x dx, when I have in particular please note that if I have this result f of x and g of x defined on a closed interval a to b, then the integral of f of x from a to b is greater than or equal to g of x from a to b, in particular if f of x is greater than or equal to 0. If f of x is greater than equal to 0. So if I have this result, then this particular result also holds true. Okay, this particular result for inequality also holds true, right? And similarly, the last form or the last type of applications of inequalities, or the type 4. So for the type 4, what I can have, that if I have a given continuous function f of x which is defined on the continuous interval a to b, if you are able to find two continuous functions, so for a given function f of x on a to b, now if I have this continuous function from a to b which are continuous, please note this is continuous, and you are able to find two continuous function f of 1x and f2 of x on the same interval a to b, and I can define f of x is lying between f1 of x and f2 of x. Okay, so the upper bound and the lower bound of the function f of x is given as f1 of x and f2 of x. So these are the bound of the function f of x. If I have this particular result for continuous result, then if I just integrate it from a to b for this function, then this will be the bound for the given integral f of x. The bounds are as follows for f1 and f2. Okay, so this is a very crucial result. Okay, please note this. So whenever you find out two continuous function which are the bound of the main function f of x, then the integral or the definite integral from a to b will also be the bound of the same function, right? Please note this result is a very crucial result. Okay, and this is always true for all x lying between a to b. Okay, for all x lying between a to b. I hope this is clear to all of you. I hope this is clear to all of you, right? Okay, now, and the last one and the last type of applications of inequality is given as, in the last form of application of inequality, if I can find the global maxima and the global minima for a given function f of x. So if I have any function and I know the global maxima is capital M and the global minima is small m, then and also please note that this is basically on the interval for x going from a to b, okay. Then whenever I integrate this particular function from f of x from a to b, this result is going from is less than capital M, which is the maxima, multiplied with b minus a, is less than or equal, is greater than or equal to minima multiplied with b minus a. So this is one of the another crucial result for the upper bound and the lower bound of a given integral function. Is this clear to all of you? Is this part clear to all of you? Please let me know in the live chat. Is this part clear? Are all these things clear? JEE वाला भैया, I am having distraction. बताओ JEE वाला क्या distraction हो रहा है तुम्हारा? Distraction क्यों हो रहा है? एक काम करो, okay? Whenever you think you are feeling distracted, like तुमको लगता है कि तुम पढ़ाई से थोड़ा हटके कुछ और चीजें करना चाहते हो, पर करने का मन भी कर रहा है, and then you get distracted from the studies. Please note that तुम्हारा ultimate goal क्या है, right? Okay, JEE वाला, please try to note that what is your ultimate goal, okay? PC, no. क्या समझ में नहीं आया ये चीज क्या? What do you mean by no? Mr. PC, can you tell me what do you mean by no? JEE wala. And if you are again feeling like demotivated or like you feel like you are basically going away from the main important topics, then definitely what you can do is that you can enroll for the one-to-one classes where you can be basically focused and preparing for the upcoming sessions. Okay, so every sessions we're going to be basically a one-to-one sessions, and then where you will be sitting with me and studying the particular topic, right? So that will be a one-to-one online classes, and in that particular classes I think you won't be able to face any distraction, right? Because there you will have homeworks, you will have assignments, you will have test, every weekly test. So all those particular thing is going to help you in order to prepare for the upcoming examination, and that will reduce all your distractions. Okay, and please note that try to use as much as try to use less of the phone on all these things, okay, and try to be less on social media, so that you don't feel distracted. Okay, just try to focus on what is your goal and what are the tasks that is needed to acquire that particular goal. Okay, so if you follow those particular things, I think then nothing can stop you from becoming what you want to get in your life, right? I hope this is clear to all of you. Is that clear to all of you? Please let me know in the live chat. Is that clear? I'm going through a live chat. Please let me know. If you have any questions, please note. Okay, if you have any confusion or any questions, please let me know in the live chat so that I can give you quick solution to that question. Okay. I hope this is clear, right? So let's quickly see some of the questions and let's try to practice some of the questions. Okay. So there is no more questions in the live chat. So therefore we can go on with the solving some of the questions, right? So let's say there is a one interesting problem. So let's say you have to estimate the absolute value for the given integral from 0 to 19 for this function sine of x whole divided by 1 plus x to the power 8, right? So to find the absolute value for this particular definite integral, how we will do that, right? So it's a quite good question, and I want all of you to please give a try, right? So if you have understood all the applications of this inequalities, I hope you will be in a position to now try that particular question. Okay, so give a try. If you're not able to solve it, I will help you out, right? Please give a try. Rakshit edit, hi bhaiya. Bhaiya, are you Bengali? Yes, I am Bengali. It's Rakshit edit. Are you able to understand this? Please try to solve the question. Please try to solve the question. Please try to look into the solution. Okay, try to think of how you can solve this question. Okay, this is a quite useful question, especially if you have understood the applications, right? And sometimes these types of questions are quite interesting, as well as this will actually help you to learn a lot of things about the inequalities of definite integrals. Okay, so let's quickly jump into the solution. Right now we have to find this particular absolute value, right? Now, in order to find this absolute value, I don't know how will I integrate this function, right? Now, the main challenge is that I don't know how to integrate this function. So, in order to solve this question, what I'm going to do is that I'm going to simply apply the first type of inequality, and I can say that this integral will be obviously less than or equals to modulus of sine x upon 1 plus x to the power 8 and mod of that dx, right? Okay, so this is basically using the type 1 inequality. Okay, so this is by using the type 1 inequality. So if I use a type 1 inequality, you will see this result is true, right? Now I know certainly that sine of x is mod of sine of x is obviously less than or equal to 1, and x is greater than equal to 10, right? So here the x is lower limit is 10 and the upper limit is 19. So x is going from 10 to 19, right? So within this interval from 10 to 19, what I can say is that the inequality sine x upon 1 plus x to the power 8 mod of it will be less than or equals to 1 upon 1 plus x to the power 8 and mod of that, right? I can definitely say this result. Now I know that the bound of this limit is going from 10 to 19. So if I apply this, then 1 plus x to the power 8, then 1 plus x to the power 8 will be obviously greater than 10 to the power 8, will be obviously greater than 10 to the power, because x is greater than 10. So 1 plus x to the power 8 will be obviously greater than 10 to the power 8, right? Now, therefore, if I take the inverse of this, then 1 plus x to the power 8, this will be obviously less than 1 upon 10 to the power 8, 1 upon 10 to the power 8, right? And if I take the mod of it, it is going to be less than mod of this particular result, which is again positive. So this is the same result, right? Or I can write this result as 10 to the power minus 8, right? So therefore now I am able to find what is the bound for this function, that is sine x upon 1 plus x to the power 8, and if I have mod of it, it is less than or equals to 10 to the power 8, which is fulfilled, right? Therefore, if I obtain the integral from 10 to 19 for this result, it is same as over here, it is less than or equals to, for this particular result, within the interval dx from the interval 10 to 19, right? Then if I do this and carry out, now this is basically easy to do it, right? Now this particular result is going to equal to 10 to the power minus 8 multiplied with 10 minus 19, which is equal to 9. So this is going to be the result, right? So we will have 9 to 10 to the power 7, which is approximately, I can write this as 10 to the power minus 7, which I can approximately write as 10 to the power minus 7, right? Now once I have this result, now I also know that the modulus value for the integral going from 10 to 19 for this function sine x upon 1 plus x to the power 8 dx will be obviously less than or equal to this particular value, right? So therefore, I am able to estimate the absolute value of the function is obviously less than or equals to 10 to the power minus 7. So now I got the upper bound of the particular modulus value. So that is something that I can comment from this particular question. I hope this is clear to all of you. Is this question clear to all of you? Please let me know in the live chat. Please let me know in the live chat. Is this clear? Is this question clear to all of you? Is this question clear? Okay, please follow the step. Just follow the steps one by one and you can get the result very easily, right? So I hope the solution is clear, right? I hope the solution is clear. Please let me know in the live chat if you have any confusion, any doubts. I will be definitely trying to answer your queries. Okay. So if this particular thing is clear, I would like to give you some homework problem to practice. Okay. Please try to solve this all questions and then you try to tell me what will be the bound of this function. Just use the simple result that you have already learned up and tell me what will be the following results. Okay. So this is a very interesting question. This is a very interesting question. Please take us note down this question. So the first question is saying that if I have a function which is continuous function on x going from 2 to 10, which is continuous function on x going from 2 to 10, and then we have the result that the mod of this particular function, the magnitude of this particular function, oh sorry, it is said that this particular function is greater than x. Okay, this particular function is greater than x. So sorry, greater than 0 for all x belongs to 2 to 10. For all x belongs to 2 to 10, and I have this particular integral going from 4 to 8 for the function f of x dx, and this result is equal to 0, right? So if you have this particular result, please try to find the function of value at x equal to 6. Please try to find the function of value at x equal to 6. Okay, so this is a very interesting problem. Please try to apply whatever you have learned so far. Okay, and the second hour problem is if you have the integral going from 1 to 3 for the function x cube plus 3 and square root of that dx, please try to find the bound of this particular integral. Okay, find the bound of this integral. Okay, please try to find the bound of this integral problem. Okay, please try to find the upper bound and the lower bound of this integral problem. Okay, I hope these two questions are clear. If you have any questions, please ask me, or else you can try to understand. Okay, and try to let me know whatever the solution will be like. Okay, so please try to solve these two questions. Thank you, Rakshit Edits. Nice explanation. Okay, please take a screenshot or maybe take a note and try to solve these questions whenever the lecture is over. Okay. Do you have any questions? Please let me know in the live chat, or else we can start with the upcoming topics, right? So quickly, I'm going to explain the upcoming topics. That is, first of all, I'm going to discuss about the gamma function, right? Now, gamma function is not that important or not that crucial, especially for the JEE syllabus, right? But if you look at the recent year JEE Mains and JEE Advanced problems, especially JEE Mains problems, you can see that there are certain usage of gamma functions, right? So sometimes knowing the results or how to integrate the gamma function or knowing how to do the recursive integration, it is very useful, right? So let's quickly see what is the gamma function. Okay, let's quickly see what is gamma function. So gamma function is basically a special type of integral if I have n is a positive, if I have n is a positive number, if I have n is any positive number, then whenever we have this kind of improper integral, this is basically an improper integral. Okay, now what is a proper integral, what is an improper integral? You will definitely learn that in university. Okay, now don't ask me that question that then why are you taking this particular topic, right? I have seen questions especially in JEE Mains, that's why I'm taking this topic. But if you want to learn the deep or want to go inside, or what is this function look like, or how this function is basically, what is improper integral, what is a proper integral, you can definitely learn all that up in your university courses, right? So where you have advanced calculus courses, right? But definitely learning about the result, how to integrate this kind of question will be actually helping you out, especially in JEE Mains questions. Okay, so those few questions that whenever you are basically fighting for the top 100 rank, those few questions actually determines your top 100, right? So definitely try to know this result and how to integrate the result, rather than asking that question what is a improper integral, right? We can definitely learn about it. If you want to learn about it, I'm definitely very happy to take a course on improper integral, proper integrals. Okay, and definitely we can also talk about how to solve questions of whenever we don't know how to integrate the integral function, right? So those kinds of questions we can take up, but that will not be in the scope of the JEE Mains and advanced syllabus, right? So whenever we have this kinds of integral going from 0 to infinity, e to the power minus x, x to the power n, e to the power minus x multiplied with x to the power n minus 1 dx, where your x belongs to some positive rational number. Okay, where x belongs to positive rational number, then this particular thing is called as the gamma function. Okay, and the notation for this is basically given as, okay, now this is basically given as by the symbol gamma of n. Okay, this is the letter gamma. So this is the letter gamma. Gamma of n is basically given by this particular integral, right? Okay, so whenever I will ask you this question, how to integrate gamma function, so there are certain properties related to it. So let's quickly see what is the gamma function and how we integrate it, right? So if I take a simple example, let us say I ask you find the value of gamma of 1. So if I try to find the gamma of 1, it is basically integral going from 0 to infinity e to the power minus x and x to the power n minus 1. So it is 0, right? X to the power 0 dx, right? So which is going to be e to the power minus x. Now it is very simple to integrate this. It is going to be e to the minus of e to the power minus x going from 0 to infinity. Right? So if I put the values, the value is going to be equals to, so please note that I cannot directly put infinity over here. That makes the question actually a improper integral. So what I'm going to do over here is that I'm going to write the upper limit as b, and I'm going to say the limit b is tending towards infinity. And in this case, the result is going to be the limit b tending towards infinity. I will have e to the power 0 minus e to the power minus of b. And then I'm going to put that when my limit b tends towards infinity, the value of e to the power minus infinity goes towards 0. And ultimately, the answer to this question, I'm going to get it is equal to 1, right? Now this is basically the result why it is an improper integral, right? Now you must be wondering that we have already solved questions where we have been integrating from 0 to infinity and we directly put the value of infinity. So you cannot directly put the value of infinity, right? Infinity is not a number, it is a concept, right? So whenever you are putting the value of x equal to infinity, it means that the limit x tending towards infinity, right? So similarly, by using the same result, we can also try to find out the gamma of 2. And that will be integral 0 to infinity e to the power minus x and x to the power 1, right? Once we have this result, now we can use the by parts. So if I use a by parts and then I use the concept that is limit b tending towards infinity, interval 0 to b and e to the power minus x into x dx, and then I use a by parts over here, then I can quickly write the result limit b tending towards infinity, and the result is going to look like minus x e to the power minus x into e to the power minus x minus e to the power minus x, right? And the interval going from 0 to b. Now if you solve this and put the value of limit or b tending towards 0 or infinity, the result is like, so we will have limit b tending towards infinity, the result is b plus 1 in minus of b plus 1 whole divided by e to the power b over here, as b tending towards 0, and we don't forget there is plus 1 over here. So as b tending towards 0, So it is infinity upon infinity form. So if you look at this particular limit, is basically infinity upon infinity form. We can simply use the L'Hopital rule, and if I just differentiate, so if I differentiate, this is going to be minus 1 upon b into e to the power minus b, right? So this will give you the result as minus 1 of, did I make a mistake over here? Right. Okay. Yeah. So I will have minus 1 upon b into e to the power e to the power b, right? So now this particular term is going towards infinity. So 1 upon infinity is again going to 0. So ultimately the result is going to be equal to 1. Right. So ultimately the result is again going to be equal to 1. So gamma of 1 and gamma of 2 is also equal to 0. Sorry, 1. Right. Now that brings us to a very important conclusion. Therefore, when you try to find out gamma of 3, you will see that this result is going to be equal to 2 into gamma of 2. Please try to solve it by your own. Okay. Please try to solve it. Please try to check it. So you will find out that gamma of 3 will be equal to 2 times gamma of 2. Okay. So that brings us to some of the important properties, that is, okay, so that brings us to some of the properties, that is, whenever we try to integrate gamma of 1, it is equals to 1, and whenever you will try to integrate gamma of 0, it is equals to infinity, and gamma of 2 is also equal to 1, and gamma of, so, and if you try to do this result, and then you try to find a higher result for gamma of 4, you will see this is equals to 3 times of gamma of 3. So this brings us to a very important recursion result, that is gamma of n plus 1, where n is an integer. Please note, n is an integer. This can be given as n times of gamma of n. Okay, now this is a very crucial result whenever you have n as an integer. Okay, whenever you have n as an integer. Okay, whenever you have n as an integer, this is a very crucial result. Okay, so with this particular property, I hope this gamma function is clear to all of you. Is this gamma function clear to all of you? Please let me know. Okay, so once this is clear, therefore now you are basically in a position to solve a very interesting problem that can be easily solved by using gamma function. So that will be third problem, or the third homework problem. Okay, so that question is integral from 0 to 1, natural log of 1 upon x, and whole to the power n minus 1, dx. Okay, so this will be the homework problem for all of you. Okay, please try to see how you can integrate this particular problem and using the gamma functions. Okay, please try to use the gamma function to get the quicker solution. Okay, and let me know what is the value of this integral. Right, so with this I come to the end of today's session, and in the next class we're going to start from this particular topic onward, that we're going to discuss about the beta function and how we're going to resolve beta function can be resolved in terms of gamma function, and then we can go to the ultimate form of the last topic, that is the Wallis formula. Right, so with that Wallis formula I will be ending the session of definite integral, and then we'll go into question solving. Right, so then we will practice lot of miscellaneous question, and that will actually help you out for your upcoming examination. Right, so with this particular note I would conclude the session over here. So thanks a lot for all of you for joining the session, and if you are new to this particular channel, please subscribe to the channel and please hit the like button. All right, and also share these videos among your friends, your relatives, and any of the people. If your juniors are preparing for class 11th and class 12th and are preparing for the upcoming JEE Mains and Advanced examination, please try to recommend this particular channel to them. Okay, these are all lectures are basically for free on YouTube. You just only need motivation and an internet connection to have these lectures. Right, so with this note I would conclude the session over here.